Physics, Sound 2. Pitch and loudness depends on frequency and amplitude. Let us try to fully grasp the point made earlier and what it implies. There are two things that are important properties of sound as mentioned earlier: loudness and pitch. Let us now understand both these facts with a deeper understanding of sound as a series of compressions and rarefactions. Let's take loudness first. When we speak softly, we are obviously putting less pressure on air, so the maximum compression or rarefaction is less. When we speak loudly, we are putting more pressure on air, so the maximum compression or rarefaction is more. So, the greater the compression from normal state, greater is the volume or loudness. Take a spoon and bang on the table lightly. The sound is low. Bang it hard. The sound is louder. Again, the same principle applies. If the pressure is more, compression is more, and hence loudness is more. A tire or a balloon bursts. That is, gives us loud sound because the air suddenly shoots out. The pressure is more, and hence the compression maximum is more, and hence the ear grasps that as a loud sound and gives us a loud sensation. Wherever there is a loud sound, there is high pressure, there is high maximum compression, and hence high volume. The maximum compression from normal state is called by the technical word amplitude. So more amplitude, distance from the mean position of the compression or the rarefaction, the greater is the loudness of the sound. So I hope that is very clear. The next question is with respect to pitch. What about pitch? What determines pitch? How do we relate the deeper nature of sound as having compressions and rarefactions with the pitch? Why do girls have high pitch and boys lower pitch? Why does ni note have higher pitch than re note, for example? The answer is that when there are more vibrations per second, that is, the number of successive compressions and rarefactions in 1 second is more, the pitch is more. This number of successive compressions and rarefactions per second is called by the name frequency. Hence, if frequency is more, the pitch is high. So you see, now we have understood why a particular sound has higher pitch or lower pitch, higher loudness or lower loudness. It depends, the pitch depends on the frequency and the loudness depends on the amplitude. It's really as simple as that. The loudness depends on the amplitude means the distance from the mean position, that is the maximum compression of the rarefaction, is more. Pitch depends on frequency means the number of vibrations per second, that is number of compressions and rarefactions per second is more, pitch is more. If the number of compressions and rarefactions, that is the frequency is less, pitch is less. So that completes in fundamental, deep terms what really is sound. Now I hope you can understand that sound is nothing but a beautiful way by which the vibrations happen in the medium. It could be solid, it could be liquid, it could be air or gas, and that's how we hear sound. I hope you enjoyed both volume 1 and volume 2 of Physics Sound. I hope you enjoyed the show. Thank you.